Okay, welcome everybody back to AP Physics. We're going to do some example problems here on projectile motion. Okay, so we're going to say that we have a cliff here, and we have an initial velocity with an angle of 30 degrees, and we'll say that this is 45 meters per second. Okay, and the things that I want to know, what I want to know is how high, okay, how far in x direction, and time to top, and then time to fall from top. Okay, so these are the four things I want to know. Well, the first thing that you have to do in every single vector question, for the most part, in this way is split into x and y, because if you're not all x's and not all y's, you're not all good. Okay? So the sine of 30 is half times 45. We have 22.5 meters per second up, and the cosine of 30 times 45 is 38.97 meters per second. Do we get agreement on that number? Okay, so now that we have this, now we don't even think about the 45 meters per second at 30 anymore. We're done with that for now, okay? So the first question is how high? Well, I think I'm going to try to figure out the time to the top first. So I'm going to go with my time to the top. Well, you can use this formula, V equals V sub naught plus AT, knowing that at this point up here, the V is going to be 0. So then you have a negative V sub naught divided by negative 10 equals time. You really don't have to do the math for this, because it's always 2.25 seconds is how much time it takes. And really all you do is say, well, after 1 second it's 12.5, after 2 seconds it's 2.5, and then it's going to take another 0.25 seconds to get the rest of that velocity down to 0. Okay? So that should become something really quick for you. So it's 2.25 seconds. Okay, now the next question is how high. So there's a couple different ways to do that. For me, I just look at it and I go, well, my average is going to be 11.25. I multiply it by the time, and I'm going to get about 24-25 meters per second, right? Now there's a couple other ways to do that. You could just go x is average v times t, or x in the y direction is 22.5 divided by 2, because our acceleration is constant, times 2.25. How high is that, people? So it's 25.3125 meters. Okay, is there another way to do that? Well, yes, there is. There's always more than one way, right? Okay, so the other way that you can do it, if you just want to be strictly kinematics equations, v squared equals v sub naught squared plus 2ax. We're looking for x. Since this x then is v sub naught squared divided by 2a. X equals, actually this would be 0, so it'd be x is negative v sub naught squared. Now you don't square that because we just subtracted it from both sides. Divided by 2 times negative 10. X then equals, oh, same answer, 25.3125 meters. Now, as long as you did all your signs correctly and everything, that should be a positive number, which is correct because our velocity is positive, so our displacement needs to be positive. And the other confirmation of that is we're saying that our acceleration, which is downward, is a negative 10, as pictured right there. Okay? So there's a couple of ways to do how high. Okay, and then the next part is how much time to fall. So right here we have how much time it went to the top. Now we have to find how much time it's going to fall from all the way up here Okay, the one thing I didn't give you is 25 meters is how high this cliff is. Okay, so we know we have 25 plus 20, another 25.312. So it's going to fall a total of 50.3125 meters. Okay, and you know, there's a bunch of different ways to do this too, but this formula works out really well. And that's because I start up here where my V is 0, and my V sub naught in this case is 0 because I'm starting there. So I X that out, and then I have my time is equal to the square root of 2x over little g. You know, that's just solving for this right over here. Make sure you show all your algebra on that. And then so my time in this case is going to be 2 times 50.3125 divided by 10. Now, in reality, this 50 is a negative, right, because it's going downwards. So it's a negative, this is a negative 10. What is my time to fall then, people? Okay, time to fall is 3.16 seconds. Okay. And then my last question was, you know, how far away from the edge of the table or the cliff is this going to fall? Okay. So it's your average velocity in the x direction times your total time. Your average velocity is not going to change in the x direction, or your velocity isn't going to change. And here we said it was 38.97 meters per second. So I'll plug that in, 38.97 meters per second. And then the time is the time up plus the time down. So we add 2.25 seconds plus 3.16. So 2.25 seconds plus 3.16 seconds. And my displacement in the x direction then is, okay, the answer is 210 what? 0.8276 meters. Okay. 0.8. I'm not sure on the rounding on that. But this then is how far we went in the x direction. Are there any questions on this? Okay, so in this problem we have some kind of velocity up here, and that's what we're trying to figure out. But we know that that velocity goes 50 meters in the x direction, and the time that it takes for this whole situation is 7.5 seconds. So that's what we know. We know that we have a cliff of 30 meters, and it takes 7.5 seconds for this thing to, you know, go from here and land over here. Okay, so what should we do first? Well, if you don't know what to do, you start writing down things that you know and things that you don't know. Okay, so I'm going to start with I have time here, so I'm going to start with a y checklist. So my velocity initial in the y, I don't know. Velocity final in the y, I don't know. Acceleration in the y, negative 10. Time in the y, 7.5 seconds. Displacement in the y, negative 30 meters. Okay, so like I said, I'm not going to help you if you don't do this stuff first, right? So now I have my variable list, and if I have my formulas memorized, V equals V sub naught plus AT, X equals V sub naught T plus 1/2 AT squared, and V squared equals V sub naught squared plus 2AX. I can sit here and I can look pretty easily and see which formula I can use, right? So once I do this, then I can realize that, hey, there's only one formula to use right here, and that's X equals V sub naught T plus 1/2 AT squared. You know, and if you look in the textbook, it's going to give you Y, like Y equals V sub naught YT, but on the AP test, you don't get that. So we're actually going for on the V sub naught, right? So we could go V sub naught T equals 1/2, equals displacement minus 1/2 AT squared. right? Or we could go v sub naught in the y direction then equals x minus 1/2 at squared, all divided by t. So v sub naught in the y direction then equals negative 30. Now if you don't get your symbols in here correctly, the pluses and minuses, this is not going to work out for you. You know, negative 30 minus negative 5 times 7.5 squared, all divided by 7.5. And you will find that this, when you put this stuff together, gives you a v sub naught in the y direction of, your v sub naught in the y direction is 33.5 meters per second, and that's a positive number, so that means that it's going up, right? So now I go back to our problem. We don't have the v, but we do have the y part of the v, which is 33.5 meters per second. Okay? So good. We've got an in, right? So what should we do next? Well, now we could do the x velocity, right? I mean, we could have done the x velocity right away with very little math, because we have the x displacement, we have the time, okay? Because it said so my velocity in the x direction, which does not accelerate, is displacement per time. In this case, 50 meters divided by 7.5 seconds. Our velocity in the x direction then, people, is 6.67 meters per second, which makes my 33.5 meters per second way too short, right? Because size means something here. Okay, so those are the two legs of our triangle, and now our resultant then is the actual, this is the actual velocity that we're looking for, okay? So v then equals the square root of 33.5 squared plus 6.67 squared. Our velocity then equals 34.158 meters per second at, okay, so we need to find an angle, so I'm going to do that one. So the inverse sine of opposite over hypotenuse, which is 33.5. Oh, can't do that. I got to do the inverse tangent, right? Over 6.67. Okay, so the inverse tangent, because that's what I have, of 33.5 over 6.67 equals 78.74 degrees. Okay, so I'm going to put 78.74 degrees above, I'm going to put positive x. And that then together is our final velocity. Any questions? Make that in final answer, initial velocity. Yeah. Okay, so here's the video question for tomorrow that you have to come in with. Let's say that I have kind of a regular lab table. And let's say that the lab table is kind of your regular 1.25 meters in height. Okay. Okay. And let's say that we have a ramp here that has a theta that's equal to 15 degrees. And let's say that we start a cart up here with very low friction wheels and very minimal mass wheels, so there's no rotational inertia. And we'll say that this cart starts at an initial velocity of 0. And we'll say that it travels down the ramp for 0.75 meters. And the transition here is without loss of energy or momentum. well, without loss of energy, okay? So whatever V you get at the end of the ramp here, that is constant, until acted on by an outside force. Okay, the table doesn't do anything to it. Okay, my question to you is, how far away in the X direction will that cart land? Okay, so come with that for sure. This has to be for sure done tomorrow, and then work on worksheet 4, see if there's any questions you have on that. Have a good day.